Okay, let's dive right in. When an AI agent is out there browsing the web, how does it actually remember what it did? How does it learn from its experiences? Well, we're going to pull back the curtain and see exactly how raw action gets turned into real, usable knowledge.
I mean, think about it. An agent can perform millions of actions on thousands of different websites. That's a tidal wave of data. Just logging, "I clicked a button," is pretty much useless for learning. So the real challenge here is, how do you turn all that raw, chaotic interaction into something structured? Well, it's not magic, that's for sure. It takes a really clever system.
And this is that system, the Lightweight Candidate Journal, or what we call the LCJ. The best way to think of it is like the agent's super meticulous diary. It's designed to capture every single thing the agent experiences, every click, every mistake, every little change on a web page, and turn all that chaos into a solid foundation for learning.
So how does the LCJ actually organize all these memories? It's not just some giant, messy text file of events. No, what's really cool is how it structures every single interaction across 3 distinct layers. It transforms a simple action into a rich, detailed story of what happened and, more importantly, why it matters.
Okay, let's start at the most fundamental layer, the tool event. You can think of this as the ground floor of the agent's memory. It's basically a simple, raw log of every single tool the agent uses while it's doing its thing on the web.
This first level is all about the basic facts, like a little report for every action. It captures the tool name, so what did it do? Something like nova.click selector. Then right away, it logs whether it was a success. It even adds the duration ms to see how fast it was, and the context host to know exactly where it happened. It's the essential who, what, where, and when that everything else is built on.
All right, moving up to level 2, and this is where things start to get a lot smarter. Here, those raw actions from level 1 get turned into specific, testable ideas or hypotheses about the website. The system isn't just recording what happened anymore, it's starting to form an opinion.
And you can see that leap in intelligence right here. The system isn't just logging a click, it's framing it as a claim. Like, hey, I think this element is a cookie banner. Then it gives it a status, was that claim verified or proven wrong, and a confidence score. Just like that, a simple action has evolved into a real, trackable idea.
And that brings us to the third and most detailed level, observations. This is the top layer, where all the pieces finally come together. It stores all the rich context and the nuanced details that are absolutely critical for any kind of sophisticated, long-term learning to happen.
This is where those hypotheses from level 2 really get their proof. The kind of observation tells the whole story. Was it a simple action success? Or maybe a blocker dismissed, which confirms the agent correctly handled a pop-up? But the real game changer here is selector drift. This logs when a button the agent knew about has moved or changed on the page. Now that's not just an error, that's contextual gold. It's what allows the agent to adapt and learn instead of just failing, which makes it incredibly resilient.
So the LCJ is recording all this incredible data, but you might be wondering, doesn't that get overwhelmingly noisy? Well, the answer is no, thanks to 2 very clever, very simple mechanisms that are designed to keep the data clean and meaningful.
First up is something called throttling. Imagine an agent just rapidly clicks the same button 5 times in 2 seconds. Instead of flooding the journal with 5 identical entries, the LCJ is smart enough to bundle them all together. It records a single observation for that action as long as it happens within a 60-second window. It's a simple idea, but it's a super powerful way to prevent data storms.
The second trick is the session cursor, which basically defines an activity session. If the agent is inactive for 30 minutes, a new session starts. Now, why is this so important? Well, because an action that succeeds across multiple distinct sessions, that's a huge signal. It proves the agent's knowledge isn't just a fluke, it's durable, it's reliable.
So let's put it all together. You get this really elegant flow. Step 1, the agent acts on a website. Step 2, the agent records that interaction with all that rich, structured context we just talked about. And step 3, that clean data becomes the essential fuel for the agent learning pipeline, or ALP, which is the system that actually does the learning.
And this right here is the key takeaway. The LCJ isn't just some other feature. It is the absolute data foundation for agent learning. Every single bit of intelligent automation, every piece of knowledge the Nova agent gets is built on this bedrock of structured, contextualized observation.
It really makes you wonder, doesn't it? When an AI's memory is this structured, this rich with context, what becomes possible? What kinds of problems can we solve when an agent doesn't just act, but it can truly remember, adapt, and understand what it's doing?